In this video, we're going to go over some derivative rules. Some of them we'll prove. The first rule is, we'll call it a theorem or a fact. The derivative of a constant is zero. How about we motivate it before we prove it by a graph? We have x and y, and f of x is some constant, 7, 4, 3. So that means y is k, always. Regardless of what x is, 7 is 7, 9 is 9. It is a horizontal line. If you were to, and the slope of this line is 0. If you were to pick this point and draw the tangent line, it would have the same slope as the green line, as y equals k. If you pick this point and you drew the tangent line, it'll be the same line. The slope is 0. The derivative of a constant is 0. Okay, proof. Suppose f of x is equal to k. Okay, so f prime of x is equal to the limit as delta x goes to 0 of f of x plus delta x minus f of x all over delta x. This is equal to the limit as delta x goes to 0. Now, no matter what you put in there, you get back k. F of anything is k. The rule is really simple. If I plugged in 3 here, then wherever I see x, I put 3. For whatever it's worth, I didn't put it, let's make this 8. I didn't put a 3 there for x. Why? There was no x. Okay? It turns out there's no x's here. So f for 3 will be k, f for 13 will be k, f of anything will equal k. F of anything will equal k. Okay. So f of this is k minus f for this, k, all over delta x. Now, k is, the numerator, k minus k, that's a true 0. It's not getting closer to 0. It's not approximately 0. It's not more than 0. It's not sometimes 0. It's 0. And the denominator, delta x, is getting close to 0, but it's not 0. If you take 0 and you divide it by a very, very, very small number, you get 0. Because this small number times only 0 will give you back 0. And some people may like to write a small number like this, 0.00001. Well, there's only one number to multiply this by to get back 0. And that answer is 0. Okay, this is 0. Delta, the top is 0 and the bottom is not 0. That's the definition that I use for a fraction that equals 0. The top is 0, the bottom is not. Okay. So this is saying that if f of x was equal to 11, the derivative is 0. F of x equals 14, the derivative is 0. F of x equals 71, the derivative 74, the derivative is 0. Okay. Let us go on to the second rule. let's state it like this. If f of x equals k times f of, well, you know what? So suppose you have k times f of x, and this means take the derivative of what's in the brackets. You can take the derivative of f of x, and whatever you get, multiply it by the k. And this is the theorem. Let us prove it. Let us call this function, I tried not to do this, but I guess I have to. Let's call that h of x. So, h prime of x, by definition, is the limit as delta x goes to 0 of h of x plus delta x minus h of x all over delta x. This is equal to the limit as delta x goes to 0. Now, h of anything is k times f of the anything. H of anything is k times f of the same thing. Oh, so h of this will be k times f of that minus h of anything is k times f of the same anything. Or you can just read it off. H of x is equal to that. This all gets divided by delta x. This is equal to the limit as delta x goes to 0. I can factor out the k. I get k times f of x plus delta x minus f of x all over h. Or I'll just divide that over delta x. I'll just divide that by delta x. Now, this here is, okay, so this becomes the limit as delta x. So we have a product here. Delta x goes to 0 of k times the limit as delta x goes to 0 of what I have boxed here, which is f of x plus delta x minus f of x all over delta x. This first limit is just k. Of course, as we spoke about earlier, when delta x changes, it doesn't affect k, times this limit. Oh, I know that limit. I recognize it. That's the derivative of f. So, what we've shown is that the derivative of a constant times f of x, you can take the derivative of f of x, which is f prime of x, and multiply by the constant. We'll use these in some examples at the end. We need to get the rules out of the way. You don't really know how to take derivatives of any f of x yet using these shortcut rules. So we can't use these shortcut formulas yet. Now, this is one that I like. Theorem. The derivative of f of x equals a line is the slope. And this makes sense. You have a line whose slope is m, okay, and you take a point on that line and you compute the tangent line. You draw the tangent line. Well, the slope of the tangent line is also going to be m. Down here, that point, that's the tangent line. The slope is m. Okay, the slope is m. Now that I motivated the derivative of our line is just the slope of the line, let's prove this formally. Okay, so f of x is equal to mx plus b. Now a couple of comments. So let's use one of the rules here. We have our sum here. So the derivative will be, the sum will be the derivative of this plus the derivative of that. But this is just a constant. That derivative will be 0. So I guess a takeaway from this theorem is that the derivative of a number times x is going to be m. It's going to be that number. Okay, so f prime of x is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. This is equal to the limit as delta x goes to 0. Now what does f do? It takes what's in here and multiplies it by m, and then it adds b. Okay, whatever. That's one strange rule. I'm going to take what's in the brackets, I'm going to multiply it by m, and then I'm going to add b. So that's f of x plus delta x minus. I'm going to take what's in the brackets, multiply it by m, and add b. Now when I say multiply by m, I mean denote that I'm multiplying it by m. I didn't multiply this by m yet, but I denoted that I was, and that I'm adding b. Okay, all of this over the famous delta x. Okay, now this is the limit as delta x goes to 0. You have mx plus m delta x, mx plus m delta x plus b. And I'm to take away mx, okay, I did. And I'm to take away plus b, which I did. And I divide the result by delta x. So just to be clean, let's write this down. Right now we have mx, m delta x, m times delta x over delta x. Since delta x is not 0, it is approaching 0, it's not 0, then this is 1. So I just get m. There wasn't even any delta x's for me to plug 0 into. And as promised, if f of x is a line, then the derivative of that line is m. And in that, f of x equaling mx plus 0, which by the way is mx. The derivative of this, that's a line, it's m. The derivative of mx is m. Okay. Now, let's do a couple of more rules. Let's state them. Maybe we'll prove them. I don't know. The next one is, well, actually, let's just number this one 3. If f of x equals that, then f prime of x is m. Maybe I stated that up here. You never know. Yeah, okay. I stated it good. Rule number 4. Rule number 4. If f of x and g of x are both differentiable, then the derivative of f of x plus g of x, the derivative of that is nothing more than the derivative of f of x plus the derivative of g of x. You can take the derivatives separately. And if you had minus f of x minus g of x, and you want the derivative of that, you can compute the derivative of f of x then take away from that the derivative of g of x. Okay. Next rule is students' favorite rule. If f of x is equal to x to the n is some real number. N is a real number. Pi, square root of 7, 3, 2/3, log of 11. Then f prime of x is, well, you bring down the power and then you make the new power of x1 less. When you take the derivative, the power comes down in front. There it is. And the new power becomes 1 less. Now, that's one of the main rules. And this rule tells us if you have sum or difference of many functions, you can take the derivative separately. Why is that? I mean, I only wrote down 2 functions. Suppose I wrote down 3 functions plus h of x. And we want the derivative of that. And you can say, oh my, this stuff is so hard. I was only told how to take the derivative of a sum or difference when there were just 2 functions. Well, when you add 2 functions, you get a function. Think of f of x plus g of x as one function. If you had x squared plus 1, maybe that's f of x, and you add 3x minus x cubed. Well, when you add those two, you get another function. X squared plus 1 plus 3x minus x cubed. You might write it in a different order, but nonetheless, you get a function. So we can think of f plus g as one function for right now. And in a moment, we'll change that. Plus h of x. Okay? So the rule says it's the derivative of the first function. It's the derivative of the first function plus the derivative of the second function. Now I'm going to think of this as the sum of 2 functions. Oh, the derivative? I know that. That's the derivative of the first plus the derivative of the second, coincidentally, plus h prime of x. And we can do this with 4 functions or 5 functions. Okay, so let us take derivatives. Suppose that f of x is equal to 3x cubed minus 2x squared minus 7x. So f prime of x. Now remember, if you have a constant times a function and you want the derivative, you can take the derivative of the function and multiply it by that constant. So when we take, we're going to take the derivative of this, and then take away the derivative of that, and then take away the derivative of that. That was one of our rules. Now, when you have 3 times x cubed and you want the derivative, well, you can just multiply 3 by the derivative of x cubed. And the derivative of x cubed is you bring down the power, make the new power of x1 less, and that gives you 9x squared. It would have been easier if we had just multiplied this 3 by this 3 from the get-go. This is 9x squared. Let's stay away from these always being the same. What if it were 4 instead? Again, it'll be 4 times the derivative of x squared, and the derivative of x squared is 2x to the 1. I brought down the 2 and I made the power 1 less times the 4. Well, just anticipate that the 2 and the 4 are going to be multiplied. It becomes minus 8x. Now, there's two ways of doing the next one. You could remember that this is a line. 7x plus 0, and the derivative is just the slope. Or you could spend time and do this. Understand there's a 1 there. 1 times 7 is 7. Make the new power 1 less. And then say, oh yeah, x to the 0 is 1. And 7 times 1 is just 7. There's the derivative. Suppose you were told that g of x was equal to 7 times 2x cubed minus 4x plus 5. Okay, well, this is just like this one. The 7 is the k, and this mess is the function. So the derivative will just be 7 times the derivative of that. K times the derivative of the function. Well, the derivative function is simple. It's 6x 1 power less. The derivative, and know this one like you know your name. The derivative of a constant times x is just the constant. And the derivative of a constant is 0. There's no need to bother to add 0. Doesn't do anything. So there's your answer. I guess we can factor out a 2 from here. 2 times 7 is 14. We get 3x squared minus 2. Okay, the calculus part is pretty simple. Just multiply those two numbers, make the new power 1 less. Multiply those two numbers, make the power 1 less. When it's 1, you don't have to put it. The derivative of a constant times x is just a constant. You can bring down the power, get 7, and then make the new power 1 less, and then realize that x to the 0 is 1. 7 times 1 is 7. Okay. Now, when it's just polynomials, it's okay. It doesn't even have to be polynomials. For example, this function is not a polynomial, because a polynomial doesn't allow the powers to be negative. Well, derivatives are even easier. They don't care. You multiply those two numbers, you get negative 10x, make the power 1 less. Multiply those two numbers, get negative 14, make the power 1 less. Multiply the 3 and the 4, make the power 1 less. Okay. But now, what if you have this? F of x is equal to 3 over x squared minus the cube root of x plus x squared over 5. You only know how to take the derivative of a constant times x to a power. Not 1 over x to a power, not a constant over x to the power, not 1 over a constant x to a power. You only know how to take the derivative of a constant times x to a power. Oh, that's simple. I'll move this to the numerator. The power changes signs. Over here, there's an understood 1 here. So this becomes minus x to the 1/3, 1 over 3. And this last term, it's fine. Just remember that x squared over 5 is nothing more than 1/5 times x squared. 0.2 times x squared. this is a constant. Okay, so we rewrote it, and now it's a bit easier to compute the derivative. You bring down the power, multiply it by the number in front, then make the power 1 less. You bring down the power. There's an understood 1 here. 1 times negative 1 times the third is negative a third x. Now, here's a nice rule. If you have a fraction and you want to take away 1, you're going to think of the 1 as b over b. So you get a minus b over b. That is, if you do the numerator minus the denominator, that will be the numerator, and the denominator stays the same. So you do 1 minus 3, you get negative 2, and the denominator stays the same, plus 2/5 x. Okay, one last thing. You were given a problem without negative exponents. You should give back an answer without negative exponents. So it's negative 6 over x cubed minus 1 over 3 x to the 2/3 plus 2/5 x. And that is your answer. Let us try another one. Suppose you were told that g of x was equal to 1 over 3x all squared minus the 5th root of x squared minus 4 over the 7th root of x cubed. So, first let's rewrite it. This is 1 over 9x squared minus, well, we'll keep this the same right now. Okay. Minus 4 over x to the 3 over 7. 3 over 7. Okay. So, the 9 stays on the bottom, but I'm going to bring that on top as a negative 2. You don't need that 1. And this is x to the 2 over 5. Minus, this is 4, x to the negative 3/7. That was all algebra, folks. That was all algebra. Bring all the x's to the top. Okay, now, notice, since it was all algebra, no line says g prime of x. Now, and only now, am I taking the derivative. And taking the derivative is simple. You bring down the negative 2, you make the new power 1 less over 9. Minus 2/5. When you take away 1, you do 2x. You do 2 minus 5, which is negative 3 over 5. Minus, you bring down this power, multiply it by negative 4. You get plus 12 over 7, x to the, well, you want to take away 1. Negative 3 minus 7 is negative 10 over 7. Okay, that was the calculus. Bringing down the power and making the new power 1 less. Now, some more algebra. Final answer should not have negative exponents. We can keep the negative 2 in the 9, but the x to the negative 3 crosses the division line and becomes x to the 3. Minus 2 over 5, x to the 3/5, plus 12 over 7, x to the 10 over 7. If you were given this one, h of x is equal to x minus 4 squared, well, you would just rewrite it. FOIL it out. You get that. Okay? H prime of x is quick. Bring down the 2, make the new power 1 less. The 1 you don't have to write. Minus the derivative of a constant times x is the constant, and the derivative of a constant is 0. That one is done. Let's do one more. Suppose you have h like this. Suppose you have h of x is equal to x times 3x minus 5x cubed. Well, nobody ever said that the derivative of this times that is the derivative of this times the derivative of that. So let's not make up these rules, folks. Let's distribute, and then we get 3x squared minus 5x to the 4th. Now I can easily take the derivative. 2 times 3 is 6. Make the new power 1 less, which we don't have to put if it's a 1. 4 times 5 is 20. Make the new power 1 less. There's the answer. Let us do this problem. Suppose that you're given that f of x is equal to x cubed plus 2x plus 1. And you want to find the equation of the tangent line to that graph at the point 1, 4. Notice that 1 cubed is 1, 2 times 1 is 2, and 1 is 1. So, yeah, 1, 4. So, what is going on is we have some graph. I don't care what it looks like. But when x is 1, I want their equation of this tangent line. Well, I know a point, 1, 4. Either I need another point or a slope. The derivative gives me the slope. F prime of x, this is f of x. F prime of x is 3x squared plus a constant times x is just a constant, and the derivative of 0 is 0. Okay, so what is the slope of this tangent line right here? It's f prime of 1. It's 3 times 1 squared plus 2. 1 squared is 1. 3 times 1 is 3, plus 2 is 5. So we know that this point 1, 4 is on the line, and the slope is 5. So we're almost done. We know that every line can be written in this form. And we know that m, the slope of the line, is f prime of 1, which is 5. So we need to find m and b. Well, we have m. We need to find b. Now, we were given two informations. One we had to find, but once we found it, we have it, and we have that piece. There's two unknowns. You better have two pieces. Well, we clearly used that m equals 5, so let's use the point 1, 4 to find b. When y is 4, x is 1. So, so 4 is equal to 5 plus what number? What do you add to 5 to get 4? And the answer is, it must be -1. Okay, so this is, so far, that was my most up-to-date formula. I started with this one. I updated it by putting what m is. But now I know what plus b is. It's -1. So y is equal to 5x. Instead of plus b, I put -1. Let us try one more like this. Suppose that g of x was equal to x squared plus 1. And let's make it plus x. And you want the derivative at the slope, you want the equation of the line at 2, 6. So once again, you don't have to graph this correctly. Maybe it looks like that, maybe it doesn't. But this point here is 2, 6. And we want the equation of that line. Well, we have a point We just need to find out what the slope is. But the derivative will give us that. The derivative is 2x plus 1. So the derivative at 2 will be 2 times 2, 4, plus 1, just 5. I think that's what we got before. So the slope is 5. Okay, so y equals mx plus b. Y equals 5x plus b. Now we need to find out what b is. So I'll use the other piece of information. The point, 2, 6. When y is 6, x is 2. So 6 is equal to 10 plus b. Well, plus b better be negative 4. 10 minus 4 is 6. Okay, so I update this, and I learned that y is equal to 5x, and instead of plus b, I write minus 4. That is the equation of that line. Okay, if you really want to see this, what was it, x squared plus x, this fact is 2. I didn't mean to put that bracket, but this fact is the x plus 1. So it crosses at the origin, it crosses at negative 1. The graph goes just like this, and at 2, that y value will be 6. And the equation of this line is right here, 5x minus 4. This completes the section on derivative rules.